On this episode of Weather Watch, we examine the benefits and challenges to developing a weather-ready nation. Then, we start our countdown to the #1 severe weather outbreak in a new Weather Watch Top 5. And finally, we'll take a look back at Superstorm Sandy and the impact it made on the Northeast. All of this and more, coming up on Weather Watch. Hello and welcome to a new and exciting season of Weather Watch, Millersville University's exclusive weather news program. I'm your host, Rachel Coulter. This season, Weather Watch is eager to bring you the latest in weather news and entertainment from around the globe. But before we begin, let's get you caught up on the weather that has made headlines this past winter season. Here's your weather in 60 seconds. Heavy rain and flooding in the United Kingdom, a typhoon in the Philippines, and our own blizzards in the Northeast highlight this edition of Weather in 60 Seconds. But for the special edition, we are going to put 2 minutes on the clock so you can get caught up on the weather events around the globe from this winter season. Here's your weather in 60 seconds. Starting in the United Kingdom, November brought heavy rainfall that quickly became a destructive flood. This came as a surprise, however, as the UK had just gotten out of an extreme drought that created water shortages all over the area. 4 people were killed because of this major flooding, and the United Kingdom suffered more than $2 billion in damages. Moving on to the Philippines, December brought much heartache as Typhoon Bopha tore through the island of Mindanao. The unexpected and out-of-season typhoon killed 902 people and left more than 600 missing. Bopha made the record books as the second most southerly Category 5 typhoon ever recorded and left the Philippines with a very costly cleanup. Nigeria also experienced a lot of rain in October of 2012, when unusually large amounts of rain created a flash flooding problem all over the area. The Niger and Benue rivers flooded and wiped away many of the surrounding buildings. The death toll reached up to 363 people, and 2.2 million were displaced from their homes. Moving over to the Americas, Argentina experienced a heat wave over our winter season that would make the record books. Temperatures got past 90 degrees Fahrenheit, only relenting to a low of 77 degrees. Due to the high demand in energy, 2 high-voltage lines failed and left over 1 million homes powerless for days. And finally, the United States was slammed with winter storms this season. However, February brought one of the most memorable to hit the Northeast. Nemo broke records as it poured upwards of 30 inches on multiple northern states and was the cause of electricity loss and flight cancellation for days. The blizzard came at a bad time as much of the Northeast was still facing the consequences of Superstorm Sandy. And that will do it for this special edition of Weather in 60 Seconds. Ever since childhood, we've been taught the basics about preparing for severe weather. But how much of that information have we retained? Weather Watch correspondent Daniel Burnt interviewed students here at Millersville University to test their weather readiness and teach us how to become a weather-ready nation.
Record-breaking snowfall, cold temperatures, extended drought, high heat, violent tornadoes, and massive hurricanes have all combined to reach the greatest number of multi-billion-dollar weather disasters in our nation's history. As a result, the National Oceanic and Atmospheric Administration is implementing a new initiative known as a weather-ready nation. This initiative aims to save more lives and neighborhoods by preparing the country on an individual basis. Here at Millersville, we too are following this initiative to prepare our campus, students, and faculty alike for severe weather and disasters. So we ask the question, what are some features already in place to aid in student safety during severe weather?
MU Alert is a way to get out to all the students that, there's a problem on campus, you need to take action. So it's a method, albeit one way, it's a method for us to get information out to the students. And then we do have an emergency management group here on campus that gets activated, whenever there's any disaster, whatever type, to take action. What's great about Millersville is we have one of the greatest meteorology programs in the world, right? So we have all this expertise here, and so what we're trying to do as the centers, we're trying to tie in the expertise from the academic world and from the meteorology world and from our earth science folks in with the local responders, whether that's the local emergency responders, obviously the law enforcement here on campus, the police department. And what we've been doing in the last year, 2 years is we're bringing all these people together for meetings so that we use the expertise that we have available. Unfortunately, people are creatures of habit. For instance, when I went to give the first presentation at one of the residence halls, and I'm asking these basic questions that to me are really simple. What if there's a disaster? We didn't have them there yet. So it's really communication and education. And I think what we have to do is start getting more students knowledgeable and more students in a leadership role on campus.
Education is exceptionally important when dealing with the weather. Having the understanding and knowing of key pieces of information, such as the difference between a watch and a warning, can be crucial during a severe weather event.
We literally argue in class for 25 minutes over whether it should be a warning or a watch and what it means, and because even for emergency managers, unless it's just something that's there in your head every day and you do it every day, and I'm being a little silly about the difference between a weather and a watch, but the reality of it is your average person on the street, oh, okay, what am I watching? What's the warning?
So we took this to the students to find out what they know about the weather. We asked them questions like, what would you do if a tornado were to hit the campus right now?
I would take my behind over to Wellness to my friend's apartment and make sure she has lots of bread and water.
Run to a basement or a room without windows.
Get in what was that?
The huddle position.
Yeah, the huddle position.
What about the difference between a watch and a warning?
A weather watch is that the conditions are favorable for something to happen, and a warning is it's been spotted.
A weather watch means you need to be alert that something may happen. A weather warning means something is about to happen or is already starting to happen, I assume.
And what does a weather-ready nation mean to you?
Having people know what to do during emergency situations or being prepared for bad weather when it comes.
With these answers in mind, we turned back to Dr. Hagelgans for his thoughts on some of the changes we will see in the upcoming years here at Millersville.
We're trying to train up as many of the resident hall assistants as possible in disaster preparedness so that they would know what to do in times of an emergency or disaster. We also run our community emergency response team training. The long-term goal is to then put those students into groups that if there were some major disaster on campus or even in the surrounding community, that we could help by having those trained students.
With the potential for severe weather to occur more frequently in the future, we here at Millersville are seizing the opportunity to develop and implement a weather-ready nation in our own backyard. Reporting for Weather Watch, this is student meteorologist Daniel Byrne.
Thanks, Dan. Last season, we brought you the exciting storm countdown we called the Weather Watch Top 5. This season, we're back at it again with a new list of memorable storms. Our own Pete Mullinax is back to count us down to the #1 storm. So let's find out which storms make the cut.
Welcome back to another season of our Top 5 Countdown. Last season, we counted down to the #1 northeast snowstorm of all time. This season, we start our new countdown that is very appropriate as we head into spring. Tornado outbreaks. We determine the severity of an outbreak by the number of fatalities and its economic impact. We start off our countdown with the #5 tornado outbreak. Typically, we view February as a wintry month across the United States, but in February of 2008, 87 tornadoes tracked across portions of the southeast. At #5 on our countdown is the Super Tuesday tornado outbreak of 2008. The Super Tuesday tornado outbreak was one of the costliest tornado outbreaks on record. The name Super Tuesday was created because the outbreak occurred on the Tuesday when the most primary elections took place across the country, leading to the 2008 presidential election. On the morning of February 5th, the Storm Prediction Center issued a high-risk outlook for western Tennessee, northwest Mississippi, and much of Arkansas. This was the first high-risk issued in the month of February since 1998. Major cities inside the high-risk included Little Rock and Memphis. The Storm Prediction Center had a good handle on the outbreak overall, having issued an outlook for the potential outbreak 6 days in advance. Out of the 87 tornadoes reported, 10 of them were ranked EF3 or EF4 on the enhanced Fujita scale. One EF4 tornado tracked 122 miles and across 7 counties in northern Arkansas, killing 13 people and causing over $125 million in damage. The Memphis metropolitan area was also struck by a couple of tornadoes, which caused major problems during the evening rush hour. The event stretched into February 6th across the southeast. When all was said and done, 57 people were killed, hundreds were injured, and over $1 billion in damages were done. With these astonishing numbers, the Super Tuesday tornado outbreak of 2008 earned the number 5 spot on our countdown. Reporting for Weather Watch, I'm student meteorologist Peter Mullinax.
Thanks, Pete. We're going to take a quick break, but please stick around as we challenge your minds with some weather trivia. Welcome back. In October of 2012, the Northeast was shaken when Superstorm Sandy made its way up the East Coast. Many were forced to evacuate as the storm tore through multiple states, and the consequences of the strength and size of this storm remain to this day. Our own Rachel Ryan is here to explain the impacts and aftermath of this memorable storm.
The 2012 Atlantic hurricane season was projected to be less active than recent years, expecting 11 tropical storms, of which only 6 were expected to reach hurricane status. October 19, 2012, a tropical wave was detected in the Caribbean. As the National Hurricane Center observed this disturbance, they noticed that within 6 hours of being categorized a tropical depression, it had reached tropical storm strength, becoming the 18th named storm of the season. Little did we know, this storm would be one of the most devastating of all time. Let's start out back in the Caribbean, where Sandy made her first appearance as a rather large tropical wave. At her peak, winds sliced through the air at 110 miles per hour atop Cuba, causing $2 billion in damages. Interaction with land typically weakens tropical systems, but Sandy seemed to adapt and overcome anything that threatened her lifespan. Though the eye wall became less defined, the area of tropical storm-force winds expanded rapidly. After overcoming every obstacle in her way, Sandy finally approaches the U.S. coastline and a favorable environment for her transformation into a superstorm. To her west is a strong frontal boundary, a pure fuel source for her as she transitioned to an extratropical cyclone. She thrived off this newfound energy and continued her path right into the bullseye of perfect conditions, centered right over southern New Jersey. October 29th, 8 p.m. Eastern Daylight Time, Sandy made landfall near Atlantic City, New Jersey, with 80-mile-per-hour winds and a central minimum pressure of 940 millibars, the lowest barometric pressure ever recorded for an Atlantic storm to make landfall north of Cape Hatteras, North Carolina. Regardless of the incredible lead time, no one could have prepared themselves for what was about to take place. The combination of landfall, corresponding with a full moon, created an area of ocean with 12-foot seas or greater, peaking at 1.4 million square miles, roughly 1% of the Earth's total ocean area. Tropical storm force winds were observed over 943 miles of the U.S. coast. No hurricane on record has ever been wider. High wind warnings were in Chicago to eastern Maine and Michigan's Upper Peninsula to Florida's Lake Okeechobee, an area affecting 120 million people. Subway tunnels in lower Manhattan were inundated with floodwaters. Gas stations in New Jersey and New York were closed due to power outages and depleted fuel supplies. By November 1st, approximately 4.7 million people in 15 different states were without power. Remarkably, just one day prior, 8.5 million people were without power. $20 billion in property damage. Between $10 and $30 billion in lost business, making Hurricane Sandy one of the costliest natural disasters on record in the United States.
Everybody wants that something, but we don't really need nothing at all.
Hurricane Sandy left a lasting impression on those affected by the storm. Regardless of incredible lead times and countless warnings, homes, lives, and businesses were forever changed. Stories of the Superstorm will be told for generations to come. But first, we need to understand the storm and the effects that she had on our great nation. If you're interested in helping the relief effort, please visit the website on the bottom of the screen. Reporting for Weather Watch, I'm student meteorologist Rachel Ryan.
Thanks, Rachel. Severe weather, for many, is the most appealing part of meteorology. It's always exciting to hear those radio alerts go off when a thunderstorm is rolling in. But have you ever wondered how that thunderstorm was formed? Mr. Weather and Haley Storm are here to explain the answer to that question in this segment of Weather Workshop.
Hello and welcome to the Weather Workshop. I'm Mr. Weather.
And I'm Haley Storm. Mr. Weather, I was just wondering, what causes a thunderstorm?
That's a great question, Haley. How do thunderstorms form? And what causes all those nasty storm clouds to carry all that bad weather with them? Well, a simple answer is that there's warm and cold air masses in the atmosphere. And when these large air masses collide, it causes an unstable environment. This leads to perfect conditions for convection currents to take control of the atmosphere, which ultimately helps with the formation of a thunderstorm.
Mr. Weather, I'm having a hard time visualizing that happening. Do you think we could show it through on an experiment?
That's exactly what I was getting at. We're going to do an experiment that I like to call crazy convection. Here are the things that we need for this experiment. First, we need 4 empty, identical glass bottles with an opening of 1.5 inches in diameter. Second, a pitcher of warm and cold water. Third, we need yellow and blue food coloring. And lastly, a 3x5 index card or an old playing card. Okay, let's first put a few drops of blue dye in 2 bottles and a few drops of yellow dye in 2 bottles. Now, let's fill the bottles with the blue dye with cold water and the bottles with the yellow dye with warm water. And let's fill it to the brim.
What's next?
Now we're going to take one of the warm water bottles and cover the mouth with an index card. Then carefully hold the card in place and flip the warm water bottle over and place it on top of the cold water bottle and pull out the index card.
Now what?
We do the same thing. We take an index card and cover the cold water bottle and carefully flip it over and then pull the index card out. Look what happens.
Wow, so during the second test when we put the cold bottle over the hot bottle, why did the solutions mix and turn green?
Well, Haley, warm water is less dense than cold water. Similar to air, warm air is less dense than cold air. When we put the less dense warm water on top of the dense cold water, it was confined to the top. When it was the other way around, when the dense cold water was on top of the less dense warm water, the less dense warm water rose, mixing with the cold water. You can see this by the blue and yellow dye mixing and turning green.
That's pretty awesome. So, Mr. Weather, how does that show convection? And how does convection cause thunderstorms?
Great question. As you know, convection is a process of heat transfer. When warm water moves into the cold water, it mirrors when a warm air mass collides with a cold air mass, or in general when warm air rises and cold air sinks. In real life, When these two masses collide, they create an unstable atmosphere. And as the sun heats the surface, convection currents carry warm, moist air into the middle of the atmosphere, which ignites a chain reaction that produces your thunderstorm.
So, when the warm air and the cold air mix, it causes an unstable atmosphere, which in turn leads for perfect conditions for storms to form?
Yes, indeed. Convection is one of the most fundamental processes in our atmosphere. Without it, there'd be no weather. It doesn't only help produce those thunderstorms that we love so much, but also those days with those nice, fluffy, cumulus clouds. Now that you have an understanding of convection currents, you'll understand how that thunderstorm outside formed. I hope you join us next time in the Weather Workshop.
That's all we have for this episode of Weather Watch. Please be sure to like us on Facebook and follow us on Twitter at the addresses shown below. You can also check out our website, muweatherwatch.com, to see our entire collection of videos. On behalf of our entire cast and crew, I'm Rachel Coulter. Thanks for watching, and we'll see you next time.